For this example, we want to take an explicit function here and we want to integrate it over this region. But instead of doing it the way that we've done before by slicing up those regions by top and bottom functions, we want to use a change of variables to make everything a little more convenient, to try to make everything go more smoothly. So in the previous example, what we did is we took the region that was bound by these four functions in this, and we developed a region instead that was a rectangle, just a straight, simple rectangle. And we did that with these substitutions. So the way that we would want to do the integral is we need to take our function here, and we need to change that to be in terms of u and v, just like you would in a standard substitution for one variable. And then we need to find the Jacobian and take its absolute value and then multiply that in before we change our variables of integration. So we're going to get to all that, but ultimately that's kind of our roadmap. That's what we want to do. So let's get started. The first thing we want to do is get that Jacobian. So if you remember, the Jacobian is the determinant of a matrix where the top row are the partials with respect to x, the bottom row are the partials with respect to y, and then each column is the partials of x, partials of y with respect to u, with respect to v. And then, let's go ahead and compute that. So the partial with respect to u, or of x with respect to u, is just 2/3. With respect to v is 1/3. With partial of y with respect to u is 1/3. Partial of y with respect to v is -1/3. And the determinant, you go top to bottom, and since we're going this way, we add, so we get -2/9, and then we go top to bottom, but slicing this way, and since we're slicing that way, we subtract, so that's -1/9, getting us -1/3 for our Jacobian. And so then from there we say, okay, 3xy is actually 3 times, if I pull out a 1/3 from this, I get 2u plus v. And if I pull out a 1/3 from that, I get u minus v. And I'm going to say that in a previous section, we developed this as a plus here. That was a mistake. Mistakes do happen, so just kind of roll with the punches. But if we go ahead and multiply that out, what we get is 1/3 2u squared minus uv minus v squared. So now we have a change into our new coordinates. We found the Jacobian, so we need to start plugging in. We have to say, all right, our region here of f of x, y, the double integral is our new double integral of 1/3 2u squared minus uv minus v squared. Now we need the absolute value of the Jacobian, du dv. And if we go over here, what we see is the u bounds go from 1 to 4, and the v bounds go from -4 to 0. And I'm going to point out that usually the u bounds are in the x direction, or are aligned more with the x-axis, and the v bounds are aligned more with the y-axis when you draw it. But I'd already drawn a coordinate system this way, so I just left it like that. But generally speaking, you'd actually see it kind of be rotated, kind of looking like, it'd be rotated. It'd be different, but it would still be a rectangle. So what we're going to find is in the du coordinates, we're going to go from 1 to 4. And in the dv coordinates, we're going to go from -4 to 0. So to multiply that out, we have a 1/9 from -4 to 0, and 1 to 4 of 2u squared minus uv minus v squared du dv. Now that's going to, when we take the antiderivative there, we're going to get 2/3 u cubed minus 1/2 u squared v minus uv squared from 1 to 4. And so we're going to plug in a 4, and then we're going to plug in a 1, and what you're going to find is you're going to have 42 minus 15 halves v minus 3v squared dv. Just, I mean, you feel free to plug that in and verify that, but that's what you should get. And then you keep going, you're going to get 42v minus 15 fourths v squared minus v cubed from -4 to 0. Now, when v is 0, all of these terms vanish. But when it's -4, you end up with -168, positive 60, negative 60, and positive 64, which gives me 164 over 9. Now, when I did this problem before in my notes, I got 162 over 9. I'm not sure why I got 162 over 9. It's possible I made a mistake here, but I don't think I did. But, you know, mistakes happen. So just be aware that that's the case. But ultimately, this is your methodology. You find the Jacobian, you plug in for the variables, you get the new integral with the absolute value of the Jacobian and the new limits. Now notice the new limits here are just constant numbers. They're not functions of these things. And in this particular one, you'd have to split it. See, because like in this one, you'd have to start here, and then you'd have to go up, and then you'd have to go up. So you'd actually have 1, 2, 3 separate regions that you'd have to worry about. And so you'd have 3 separate integrals to do this, and that's no fun. Whereas after the change variables, it's a little more work up front, admittedly. But you get something that's a lot more straightforward, a lot easier to handle, and a lot easier to verify.